Okay, so word problems, I'm actually going to start here at the bottom. Okay, so this is a parabola. And this parabola, this quadratic equation, was representing me launching a ball. I launched a ball. Would it make sense that when you throw something, it looks like that pattern, right? It goes up and then it comes down. Okay, do you notice the difference between just a graph, this is just a graph, and then now it only looks like this? So I chopped this part off and I chopped that part off. If I'm launching a ball, and this is the time it's taking and this is the height it's taking, why would I have chopped these parts off? Why don't they even make sense connecting to a real life situation? So why is this not making sense over here? Any ideas? Looking at your variables. Time is negative? Does that make sense? Yeah, it doesn't make sense. So then I cut this off. Okay, why did I chop that part of the graph off? You threw a ball. What happened? Why doesn't this make sense with this ball? The ball starts digging into the ground. Okay, so that didn't make sense either. The ball is now under the ground. Okay, so a y-intercept. A y-intercept looks like this, 0, comma, a number, right? That's how it would look. What does the y-intercept mean in this situation? I launched a ball and it did this. So what is the y-intercept representing given the context? Can you picture me standing here, I throw a ball, and it does that. What is the y-intercept? 0 is the what? 0 time. So that is the start. So it would be the height at the start. Would that make sense? Whatever that number is. So I can see it. It's 50, but 50 what? 50 is the height I'm starting from. Okay, so then the next point is the vertex. What does the vertex tell me? So there would be an x number and then there would be a y number to this. That's how it would look. It'd be something comma something. Okay, would this make sense? Whatever number is here would tell me the when it reaches highest. It'll tell me the when. How long does it take to go up to the top? That's what it would tell me. How long or when. So what would this part of it tell me? What is the highest height? So this is the time part of it, and this is the height part of it. X comma y. When it's doing it, and what is the height? So do you see me connecting to my variables? Then we have an x-intercept, which would be a number, comma, 0. Okay, so there's a 0 here. Well, what is the 0 in the spot for? There'd be no height. So What is going on if there's no height to something? What is it in the real life then? Ground. So this would represent when it hits the ground. Would that make sense? How long does it take till it hits the ground? Okay, so that is on your test. An explanation. So when I ask you on the test, I don't want you to say the y-intercept is 50. I want you to say the y-intercept represents what? Words. Give me words. Okay, number 3. You have a frog, and it's sitting on a rock. You ready for my amazing drawing skills? What does a frog even look like? There we go. There's my frog. Not bad. Frog. And then it jumps into a pond. So a frog would jump. Hopefully it jumps upward, and then it lands in the water. Okay, so this parabola is downward. Would that make sense? Because look at the equation. Negative. That's the slope. That's negative. So it's a downward parabola. That makes sense. Okay, question 1. How long does it take for the frog to reach its max height? What is the highest the frog reaches? So what coordinate am I worried about? Do I really want this one, or this one? With those questions, what am I concerned with? Am I concerned about the y-intercept, the vertex, or the x-intercept? The vertex. I'm only concerned about the vertex. Because all these questions talk about the highest it goes, which is the vertex. Okay, now you have to know this part. If I'm given the equation, what kind of strategy do I do to find the vertex? So look at the format. How do I find the vertex? Are you doing a negative b over 2a plug-in method? Okay, negative b over 2a is the method. So negative b is negative 150. 2 times that a number. When you type it in, I want you all to type it in because this is tricky. Let's make sure we type it in properly. The bottom part, I'm going to put brackets around it. And I want you to go to 2 decimal places. I got 0.15. So the 0.15 comma, how do I get that part? Plug it in. So negative 490.15 squared plus 150 times 0.15. So this is me plugging it in. And I'm going to go 2 decimal places. Okay, so this is nothing new. Now we're connecting it to questions, so this part's new. How long does it take? So which part is the how long part? The first part or the second part? First. So how long does it take? 0.15, and you should answer something with that. Do you know what you want to answer with it? 0.15. Here it is, seconds. That's the answer there. And then what is the highest it got? And then that would be the 36.48. And then we're going to write centimeters on that one because it told me. Okay, so the vertex. Okay, we're jumping to number 1. We'll do this order. Okay, you're having a concert and you're trying to make money. So, here's what we're going to do. The revenue. Would it make sense if I did my ticket price times the number of people? Would that make you the money? However much your ticket is times the people that come is how much money you make. Does that make sense? So right now, if I'm having a $9 ticket and 200 people are coming, I should make $1,800 right now. But I'm going to try to adjust my price to see if I can get more money out of this. Okay, so here's what I want to do. I'm going to go 2 brackets. So I'm going to start with the ticket price. And our ticket price started at $9. And 200 people came. Okay, so this is the part where it gets tricky. For every $2 increase, 10 fewer people will come. So I'm going to make those adjustments. So increasing the price by $2. So if this goes up by $2, then this would go down by 10. Okay, but we're missing something very important, and that's going to be a variable. Okay, I don't know if I'm going to increase it $2 or if I'll go up 2 and then another 2. I don't know. I'm trying to test that out. But if this changes, this also needs to change accordingly. So technically, if this goes up 4, this would go down 20. You see what I'm doing? It could do anything. Okay, that's the tricky part. Now the rest is math that you know how to do. What should I do right now? What kind of just plain old math would you do with this? Something from your past that you learned last year. If you had a binomial times a binomial, just math, what would you do? Foil it. Okay, so give me the foiled out version of this. Okay, so there's our equation. So now we're into the exact same situation as question 3. We have an equation, and now we're trying to find a max revenue. So how do you find maxes? If we have a quadratic, this is a negative quadratic because it's a negative 20 is what I'm looking at. How would we find the max? What special point is this called? A vertex. Okay, so how do you find the vertex when your equation looks like that? What's your strategy? Negative b over 2a, plug in. So negative 310 over 2 times, is everyone identifying the a as the negative 20? 1800 is not my a. Even though I wrote it first, it's actually my c. Okay, don't be tricked with that part. Okay, so we can plug this in. Was everybody matching that x value that I'm using? Okay, so I found the vertex, and actually this and this, nothing answers my question. My question has nothing to do with this number or this number as an answer. What ticket price should we sell to get our highest revenue? 7.75 is actually not the ticket price. 7.75 equals X. Not the ticket price, it just means X. And this equals Y, which is not Y, it's actually revenue. So this is my largest revenue, but this is not my ticket price. Okay, so here's what we're going to do. We're going to go back to our words. This is ticket price. Therefore, we substituted it with this is the ticket price. This is where I'm going to go with my X number. So this X number can go into that bubble. Ticket price. Okay, if I asked you what's the largest revenue, boom, that would have been your answer. But I didn't ask you that. What's the ticket price? So the ticket price is 9 plus 2 times, and then I'm going to plug the 7.75 in there. So I should be charging $24.50 for these concert tickets. That's my answer. Okay, last question, and we're burning out. Do we need to do a stand, like jumping jack thing? We're looking tired. Yep, let's do it. Stand. Everybody's tired and looking. You got one to go, and it's a hard one. Okay, this is the little bit of a harder one. Okay, here we go. You have 240 meters of fencing, and you're going to take a rectangular pen, and you're going to cut it into 3 areas. Because I'm going to put my cows in that section. I'm going to put horses in that one. And I'm going to put sheep in this one. That's what it's doing. It's cutting the 3 parts. Okay. I need you to write me lengths and widths. So we're going to go length, and then we're going to call these the widths. And you're going to need a strip of fence there, and you're going to need a strip of fence there as well, right? Does that make sense? Okay, first step. If you add all those lines of fence, it's going to make 240 meters. Okay, does that make sense what I'm saying? If you add up all those pieces of fence. So I'm going to write that in math. If I add up all those pieces of fence, that's me putting my words into math, it makes 240. Okay, some of you probably were like, I want to throw meters on that. Don't, because it's just going to confuse you adding more letters. Okay, step 2. We're going to find the largest area. So area of a rectangle is length times width. And I'm not going to tell you that on the test, so I expect that you just might know that. Length times width. Okay, here's the situation. We're going to find max area. We're going to need a quadratic. That's what happens. To get max, you need a quadratic. This has 2 letters in it instead of 1. So the goal, we're going to work here to get a letter and substitute. Which letter looks easier to get alone? The L letter or the W? The L, because there's fewer of them. So I'm going to do this. I'm going to subtract 4W. This is algebra. Subtract 4W. You can't put those together, so don't try to put those together, right? And I'm going to divide by 2, and once you give candy to one child, you have to do that to every child. Okay, now here's the situation. I am going to take this, and is it legit to put it in place of that L? If this is equal to L, does it make sense in math that I can replace it? Okay, so this is a substitution. If this is equal to L, I can replace it in the spot for the L. Okay, everything here is the same from the last question. What do we do? We're getting to our equation. We're making our equation, so we need to kind of FOIL it out, right? Same steps. Okay, remember what the goal was. We're trying to find the max. And this is a downward parabola. So how do we get the max on it? Vertex. The vertex process is negative b over 2a. So negative 120 over 2 times negative 2. What does the 30 represent? What letter? What variable? 30 is normally, we just say the x, but it's not. What letter is it instead of x? W. The W is instead of the x. So 30 equals the width. So we already know that. So here's the question. What dimensions? So I already know the width equals 30 meters. There's part of it. And if you plug it in, it actually tells me what? If I plugged it in, it would tell me the area. I don't want that. Okay, you could plug it in, but it would just tell you area. I want the dimensions, so how can I find the length? What would I do to get the length? I'm going to go here. This is where I would go to get a length. So 120 minus 2 times 30 leaves me with a length of